Yes. Okay, welcome back again, dear students. Here we are. We finished in the 10.1, which was 100% depending on what? On limits. Now, today we have series. When I say series, means that something like that. So in 10.2, we have series. And here we are going to cover three cases, three types. The first, we have geometric series. The second, we have telescoping. The third is NTT for divergence. So if you don't know from now, if you don't know how to control them, how to distinguish them, it's like an integral. For example, I gave you integral. If you don't know which type is perfect for that one, you don't know how to solve it. The same thing is here is true. If you don't know which type is geometric series, which series is like a geometry, so you don't know how to answer. The same thing is true for TD, the same thing is true for all of them. So from 10.2 till the end of this chapter, we are going to talk about series. So sequence finished, just one section. Here we are. You can see from your lecture, we have series like that. For example, we have 1.2n. What's the difference? Look, we have 1.2 to power n. For example, I say n start from 0 to infinity. So what do you mean by that? If I put 0 instead of n, I will get what? Huh? Equal to 1. So I'm going to write 1 here. Understood? If I put n to be 1, I'll get what? 1 over 2 to power 1, right? Which is equal to 1 over 2. So I'm going to write like addition. So 1 over 2. So if I say n is equal to 3, so I'll get what? 2. I'll get 2 to power 2. So I'm going to write plus 1 over 2 to power 2. Or you can write 4 or 8 or whatever you like. I would like to mention something here. So let me check for you. The Google, Gauss, I have something for you. That man mentioned the summation when he was in the first grade or grade 1. So the teacher asked him to add from 1 to till 100. So he thought that he was in the grade 1. Okay, so he think that during that time, you see, if I add the first and the last, I'll get what? 101. So how about 99 with 2? How about 98 with 3? And go on. So how many 101 we have? No? 50, you are right? So he say that from n, from 1 to 100, instead of plus 1, 2, 3 together, we are going to summarize them. I will put this formula and I can add them. Let's see how and the teachers ask what's that? You say, for example, if I have hundreds, n is 100, I have 100 multiply 99 over 2 is equal to that result that you want. So instead of adding 1 by 1, 1 plus 1, 2, 2 plus 3, 6, 6 plus 4, 10, 10 plus 5, 50, and go on, instead of that one, you can write down like that. N from 1 to 5, for example. So means that n is 1, 2, 3, 4, and 5. And you add all of them, you'll get 15, for example. Understood? Understood? Good. So this is the idea how the history about the summation, the history about the Gauss, the history about series. So the series is adding, it's not like a sequence. But in the sequence, we see just mentioned like that. We say, for example, n, we say 1, 2, 3, 4. we didn't add anything, right? We didn't add. But here, when I say summation of n, no, we add them. We mean the addition between them. Understood? Okay. Some of them is finite, some of them is infinite. When I say n from 1 or 2 or 0 to infinite means that we have infinite series, right? And we are dealing with that one. We are going to study that one. Which series is converge and how, and which series is diverge and how. So these are remarkable. Be careful, and we will use such way to find them. So that's why I say in the 10.2, we have geometric series. So at the beginning, I'm going to the geometric series. So you can see, for example, between, I gave you that example for some, in some book is like that, from n from 1 to infinity, you'll get again 1, 2, sorry, 1 over 2, 1 over 4, 1 over 8, and go on. Why we call them geometry? Because between these and that, we have R ratio. How? For example, if this is the first term, second term, third term, fourth term. Okay. If I divide T4 by T3, I'll get what? 1 over 2, right? If I divide T3 over T2, I'll get what? 1 over 4 divided by 1 over 2. Again, 1 over 2. How about the first and second? So you can see there's a ratio, right? There's a ratio. Or you can say if I multiply first term by 1 over 2, I'll get the second. Second by 1 over 2, I'll get the third by, and like that. Understood? So there's an R between them, the repetition, the ratio that make you like a bouncing, anything that you have. So here we are, we see that there's a R. Okay, now I'll give you another example. 2 to power n. So how about that one? For example, if n start from 0 to infinity, I'll get 1, 2, 2 square, 2 to power 3. Am I right? So tell me about the R. R is equal to what? Here. 2, right? If you divide that one by that one, 4 by 4 by 2, you'll get 2. 2 by 1, you'll get 2. So R is what? Is 2. So how we distinguish the geometric series, or how is different between geometric series and the rest? We say we have R. Understood? That R is not, you cannot find the other series. Okay? There's a nice, that's why we call geometric. They are increased geometric, decreased geometric, not in the one of them 1 over 2. That's it. Understood? So that's why we say the geometry. For example, if I have such series like that, 1 over 2, 1 over 3, 1 over 4. So tell me, R equal to what? Are you sure? So term 2 by 1, 1 over 2. Okay, how about term 3 over 2? Another thing. How about, so there is no R, right? So that one is not geometric series. It's serious, but it's not geometric. It's harmonic. Later we'll deal with that one. Exactly. We should have an R, and in each term it should be equal. To get it, just do like me. Third term divided by the second by one first, and you will find the R. Understood now? So geometric series, how we deal with the geometric series? Where's convergence? Where's divergence? So R decide the R. If R between 1 and -1 is converged, otherwise R diverge. So tell me about these examples. For example, I have 1 over 3 to power n, and I have 3 to power n. In that one, I'll get 1, n from 0 to infinity, n from 0 to infinity. So I'll get 1 over 3, 1 over 3 square, 1 over 3 cube, and go on. How about here? 1, 3, 3 square, 3 cube, and go on. So in the first term, in the first series, okay, converge. Why? Because R equal to what in here? In AN and BN. So in the series of AN, right, R is equal to 1 over 3. And I'm asking myself, R between 1 or minus 1? Yes, right? Between that one. So in the second one, BN, R equal to 3. So R is otherwise, right? Because R is not between 1 and minus 1. That's why I say I say that one's converge, that one is diverge. Did you understand? It's easy, right? Just look at it, find R and decide. Nothing else. Understood, Jamaat? Good. So sometimes we have with minus, alternating with minus, like n, for example, 2 to power n. So what's the difference between that one and the other one? We have what? N from 0 to infinite. I'll get what? If n 0, I will get 1, 1. If n is 1, I will get what? Minus 1 over 2. If n is 3, is 2, sorry, I will get what? Plus 2, 2. Minus 1, 2, 3, right? Plus and go on. Understood? You know why? Because we have minus 1 here. That's why I got the same thing with the alternating sign. Plus, minus, and go on. So tell me about R. R equal to what here? Yalla. Just divide it. Minus 1 over 2. Thank you. R is equal to minus. Tell me, it's converge or diverge? Wow, you are right. Absolutely. Because R between 1 and 1. And here's so is converge. That's it. If you listen, you know how to answer. And you don't need study. Because if you recognize it, it will stuck in your mind and you remember. That's all. So here we are. Here's about the first term, second term, all these that you need. Nth term, so we have an infinite series, good. And we have we can symbolize it like that or like that. K from or nothing here. When we don't write nothing, means that n from 1 to infinite. Understood, Jamaat? This is just symbol. And here's about the type of series. And here's the first type of the series, geometric series. So we have what the general form is like. What the general form is like AR n minus 1, AN, for example, n from 1 to infinite. So I will get A naught, or you can see from A1. I don't know. Yeah, you don't need to. Okay. So we will have A1, AR square, AR cube, and go on. What's R? R is we got the ratio, and we depend on the R. And he told you if R between 1 and minus 1 is converge, otherwise diverge. And if it's converge, if it's converge, we can find the sum value is equal to what? For example, you say from 1 to n from 0 to infinite. You say is equal to 1, 1 over 2, 1 over 4, 1 over 8. So, and you say it's converge to where? Right? So give me the result. So the convergence is like that. You find like that. You see the sum of this series, geometric series, if it's converged, if is equal to what? Equal to A1 minus R. What's A? What's A? A is the first term. Understood? A is the first term. For example, in my example here, A is what? Is the first term. So I see is equal to 1 minus, what was R? It was 1 over 2. And find the value, you find the geometric series sum. Look at here. Here's about the series. Here's about the examples. Another example talking about R. And here's the rule that you need. Summarize that on here. You say if R is converged, then summation that we have is equal to A over 1R plus minus R. Actually, about the series, just we can find the sum of that one here, just geometric series. So don't worry, just we have that one. So that one is converged, that one otherwise diverge. Now, 1 over 9, I'm going to the other example, 1 over 9, maybe minus or plus 1 over 27, plus 1 over, I don't know, 81, and go on. So, because there's a repetition, because there's a R, if I divide 81 by 27, I'll get 1 over 9, right? If I divide 27 by 9, I'll get what? No, 1 over 3. So 1 over 3 and 1 over 3. So because we have a R is equal to 1 over 3 and it's converged, I can see this geometric series is like that. 1 over R to power, for example, n, where n start from 2 to infinity. Am I right? Why n from 2? Because I know 3 to power 2 is equal to 9 to power 3, 27, 4, 81, and go on. So that's why I changed the index here. Okay, don't worry about that one. So is converge or diverge? Converge, because R equal to 1 over 3 and between 1 and minus 1. Okay, good. So tell me about, if it's converged, how about the summation is equal to what? I see the summation is equal to A, 1 over 1 minus R. So where's A? 1 over 9, right? Is equal to 1 over 9 and 1 minus 1 over 9, right? 1 over 3, and you'll get the result. You can see you'll get 1 over 6. How? Because 1 over 9, 3 minus 1, we need a common denominator LCD. And I think I provide you by the video, right? Okay, good. So that one will be 3. And how about that one? Is equal to what? Is equal to 2. So y is equal to that one? Where is wrong? 3 minus 1, 2. Okay, so yes, why? Where's 3 over 2? You are right. So what was wrong in here, the common denominator? So we say we have 1 over 9. You can see 1 over 9, 1 over 9, 1, 1, 1. So why we didn't get 1 over 6? Okay. We have 1 over 9 in up, right? Then here we have what? We have common denominator 3. So I'll get 3 minus 2. And I'll get what? 1 over 9. So I'll get, 2 over 3. So I cannot do anything. I say is equal to 1 over 9 multiply of what? 3 over 2. Then I'll get what? Understood? Good. So that's all. Because we should be careful when you do that. We don't say 1. I'll get 2. Good. Any question about the result, about the common denominator? So tell me about that one. Minus 1 over 5 over 4 to power n. It's a little bit different. Minus 1 and 5, 4 to 5. So tell me about n from 1. I think yes, n from 0 to infinity. Yalla. Expand the terms. Yalla. It's like actually like a game. Yalla. Expand the. Look at here, Kak. Look at here. we have another two ideas. The first, this number 5 has no n. You know, if in x dx, if there is b, right? If there is number, you can bring it to out, right? Because there is no x, even in the limit. If I have 5x and x approaches to 0, so I can bring this one to out, right? Because there's a number. The same thing is true for here. You can solve that one by 2 or 3 or using the properties, up to you. You can bring it to out and you get minus 1 over n over 4n. And I say is equal to 5, and the series will be what? If n from 0, 1 minus 1 over 4, right? Plus 1 over 4 squared minus 1 over 4 to power 3, and go on. Am I right? You can solve that one. And here we are. We have what? I can say it's 5. That one is what? Is geometric series. Am I right? R equal to what? Minus 1 over 4. Converge or diverge? Converge. So the summation is equal to what? A1 minus R. Am I right? And A is equal to what? 1 minus was equal to 5, 1 over 1 plus 1 over 4. Am I right? That's all. And you find the result. Then you multiply by 5. That's the first idea. Do you have any question? It's easier. Or as a book, as your lecture note, you can do like that. Sorry, n 4 to power n multiply by 5. Okay. So I see is equal to 5 when n equal to 0. Why? Because 5 multiply 1 plus 5 minus 5 over 4 plus 5 over 4 squared minus 5 over, and go on. Am I right? Okay. So now tell me about R. R is equal to what here? Again, minus 1 over 4, right? If you divide by 1, look, term, third term divided by second term, I'll get what? This is the third term. So I'll get 5 over 4 squared. 5 over 4. 4, 4, 5, 5. I'll get 1 over 5. Right? 1 over 4. And again, divide T2 by T1. You can see minus 5 over 4 over 5. And I'll get what? I'll get minus 1 over 4 again. So R is equal to minus 1 over 4. Where is A? 5. Thank you. Here's A5. So I see is equal to what? I see the summation is equal to A 1 minus R is equal to 5, 1 minus 4. Understood. The same. It's equal to the same. Later we multiply, or we bring it, or we put it in the first step. Does not make a sense, does not make a change. All are the same. Understood about geometric series, dear? Easy. Here we are. You have A, R, and you get the number. That one is one of the application of geometric series. I'm going to, this one is not included for exam, but you can see there's application, especially for reports. You can benefit from there. Where's the application? When you are, when you're dropping a ball from the highest to the somebody else, you just throw it. You saw the ball is balancing, right? Boom, boom, tick, tick, till still to where? Till stopping, right? So second time, half, and stopping. So that one means the convergent geometric series. Why? Because you can see here, but there's a difference. Here's instead of R, we have 2, because 2 times that one AR, A, and that one A. So that's why we have 2A, and there's a ratio R. And again, AA, and we have what? Another R squared. So you see A, 2AR squared, and go on. Understood? Good. So you can read this example and you know how to deal with it. Any question about the application? Kindly read it. You will see this many things, talking about many things about bouncing ball. Okay. Example number 4, which is one of your exercise, also one of the in your homework you have one of them, is what is expressing repeated decimal to the ratio of two integers. It means that instead of writing 518 over 99, you write what? You write 523, 23, 23, and go on. In your lecture note, you have 0.777 as a homework in your exercise. So is equal to what? So that one is decimal form. And that one is what? Is a ratio form or quotient. So you can how to express as a ratio. Okay, for example, you say 1/3 equal to what? 1/3 or 1/10 is equal to 3999. I don't know, right? 1/3. Okay. Are you sure? Can you do it by calculator? Because I'm not sure. So how to deal? I can find that one later. I can, but we don't have a time to do it. 1/3. Good. Okay. So how we express this decimal as two integers? Integer 1, integer second integer number. So these one is a ratio. How we express that one? How we get that one? Done by what? We have many way to expression, but by using geometric series. Use geometric series. So we are going to the example, and you know how's the number. So you have 5, 2, 3, 2, 3, 2, 3, and go on, right? I can write down like that, 0.23, 23, and go on. Am I right? Understood. Also, you can write this one as a 1/23 over 100. Am I right? For this digit, right? How about for the other? How about that one? The green one is equal to what? You are right. Thank you. And how about the other one? 2, 3, 100 to power 3, and go on. Am I right? So you can see from here, there's something similarly like what? Like a geometric series. So where's R? Or let me make it easier for you. Is equal to what? Am I right? Did you understand from that step? Yes. Good. So we can bring it to out as a previous one, as a number 5. So we can bring it to out, and I see here 100%. It's very clear. We got geometric series. R equal to what? 1/100. So from here, I can decide that I have 223 over 100 multiplied by A 1 minus. You got it, and you will get the result. It's easy. You'll get the result. 100 over 99, 1, and multiply 23 to 100 and plus 5, and we get the result. So here we are. We got 0.99 because we know 99 over 100 is equal to 0.99, and you multiply, we got that number. Shall I do it for you, or you can do it? Hello? Do it. Can we do it? Okay. Till here is clear, right? It's clear. Okay. We have 1 over Common denominator, 100 minus 1. Am I right? And you know is equal to 5, 2300, and equal to 1 over 99 over 100, right? And you know 99, or you can do whatever you like. We can write down like that is equal to 5, 23 over 100, and that one will be what? 100 over 99. Am I right? We bring this one to up. We have A over BC is equal to what? Equal A CB. Here in my example, A is 1, B is 99, C is 100. So it's equal to what? A in its place, A multiply C, B, 99. That's why. Okay. Now, you know, that one will cancel that one, and I'll get what? 5 plus 23, 99. Common denominator is what? 99. So 5 multiply 99 plus 23 was equal to 100. Understood? Good. Now we change what? We change 5, 23, 23, and go on to like that. In some books, can be written as like that. Maybe in your homework or exercise, I don't know. You can see it's like that. What do you mean by that? It means that the repetition is 2 digits, like a 23, 23, 23. When I say 0.7, means that I have 0.777 and go on. Understood? Do you have any question about here? Dears? Okay. The second part of 10.2, we finished the first part. So keep this one till the end because we will use it many, many times geometric series. And in the second, we say telescoping. What do you mean by telescoping? You can see from here, we have n plus 1. Look. N from 1 to infinity. N from 1 to infinity. So let me expand the series. Maybe you see it's geometry. You just heard about geometry. You see it's geometry. But expand and you see. So if n is 1, I will get what? Huh? 2. 1 over 2, right? Second, if n is 2, 2, 3, I'll get what? The third one, if n is 3. Am I right? So come. First term, second term, third term. Yalla. T3 divided by T2, you'll get what? Am I right? Okay. How about T2, T1? So you are 100% that sure about that. This one is a geometric series. Why? Because of the geometric series, the R should be equal. So that's why that one 1 over 3, and that 1 over 2, maybe that one over something else. Understood? So it's not geometric series. You got it? Dears? Good. So how we deal with that as not geometric series? We are going to change like that. Okay? We change to like that. Okay. And now expand. You'll get what? Yalla, expand. If n is 1, you'll get what? 1 minus. Okay. Plus next. If n is 2. And 3. Go till 1 over n minus 1 over n plus 1 and go. Understood? Right? you can see from here, these two cancel each other, am I right? And that two cancel, and that with the previous one, right? So next one, and that one with the previous one. So if I stop here as a k, I can see, if I say let me k like that, k and k stopped here. So I say this k will delete with the previous one, but that minus what remains, right? So it remains what? The first term and the last term. So it remains 1 minus 1 over k plus 1. Am I right? Can you imagine? Why? Because we can see 1 over 2 eliminate the second. 1 over 3 minus 1 over minus 1 over n 1 over k with the previous one. So it remains what? It remains the last one. Okay. So our series is equal to that. So our series from 1n minus 1 over n plus 1 is changed to 1 minus 1 over k plus 1. And we know that one is go to where? So we say k equal to where? K, let k to where? K also should go to where? Am I right? So how we do that one? I'm going to take a limit. I say k goes to infinity from 1 over 1k plus 1. I'll get what? Limit of 1, 1. Limit of 1 over k. Hello? 1 over k is equal to 1 over infinity plus 1 is 0. So I got what? Our series from n plus 1 changed to 1 over n minus n plus 1 and is equal to what? 1. So converge or diverge? Converge. Okay. I have one simple question. Okay. How we change that one to that one? Because nobody asked me before. I say that one's equal to that one, you say yes. How? I know, but how? If you have that one, you can decide you get that one, right? I know that's the common denominator, but tell me how I change that one, how I imagine that one. That's my question. Why is negative? Why is 1 over that one, 1 over that one? How will you separate them? You are right. How? That's my question. You can, if you have that part is right, you are right. From right, you can get the left. But from left, how do you get the right? Now I change to something. You remember, maybe you remembered. Change to what? Right? And when you find A, will be 1. When you find B, will be minus 1. So you use what? Partial fraction. Understood? So now, now I'm we are going back to the previous things. In the telescoping, we are using partial fraction. Then we separate them. Then we find the value. There will be cancellation between terms. There's a cancellation between terms. Look at here, please. Cancellation, cancellation. Then the first term with the last term remains. And after that one, we will take a limit. So here we are at 3 things. First, make the partial. Second, expand the terms to get the first and the last. Then third, take a limit. If you get the value, it's converge. If you get the infinite, and also there is one tip in your homework, in your you can see in your exercise. Here we are. You have a part of telescoping. I think we select some of them. I think I select one of this one. I don't know which one. So you can see this is telescoping. That one's ready telescoping. That one also is ready telescoping. If it's not ready, you should use partial fraction. Understood, dear? Question? Hello? Question? Good. So how many types of the in 10.2 we covered? 2 types. Geometric series has got R, and R should be between -1. And also telescoping, which is not, they don't have any rule. Just we should expand it and we get the result. So expand or partial fraction. Okay. In the third one, you have entity. Entity is very, very important. Like a test screwdriver, for the electricity, you say it's a positive or negative. in Kurdish. So it's like that entity. You can use for all of them, but it cannot cover some of them. So here we are, listen carefully. Here's entity. Entity means what? Nth test term for divergence. Okay, so it's using for what? Just for divergence. Will give you the answer is what is diverge. Otherwise, he cannot decide converge or diverge. Okay, listen to me. He say that if AN is converge, then AN is tends to 0. And entity say what? This is the importance. A question dilated. Read this question, which I am going to mention here. If AN is diverged, AN is failed to exist or different from 0. So I have AN by entity. I'm going to take, for example, I say AN equal to N plus 1 over N. So how to deal with the N? Entity is using limit. We are going to use limit. Take care. So we see limit of N approach to infinity. Where's AN? N plus 1 over N. And we are waiting for the result. If it's 0, entity fails. We cannot decide. We are going to use something else. If it's number, any numbers, we say the series diverge. If first does not exist, sorry, does not exist, also the series is diverge. So entity, I can see like that. Does not exist, numbers, I might say diverge. 0, we can not decide. So we should use another test. So I'm going to explain by the example. I have 2 examples, look at here. N plus 1 over N and 1 over 2 to power N. Understood? So I have AN and BN. So which one is converge? Which one is diverge? I am going to use entity first of all, because I told you it's a very important, so use it. So I say for AN, N approach to infinity is equal to what? Limit of N approach to infinity, N plus 1 over N, equal to what? 1. So you say directly, you say AN is diverge. Understood? Because I got the number, it's not 0. How about the second? BN, limit of N approach to infinity for BN, is equal to limit N approach to infinity 1 over 2 to power N, is equal to 1 over what? 1 over 2 to power infinity? Infinity. So 0. So I say entity is not useful here. Okay? So you should go to use the another test. Like what? I say Bn is geometric series R equal to 1 over 2 is converge. Understood? So we cannot use entity for 0. You don't see converge or diverge. Just leave it. Or go to use another method, another test, another way. You got it or not? Understood, Kaka? Good. So here we are. Yes. Mm-hmm. 0 over 0 indeterminate form. So you are going to use L'Hopital's rule. There's a limit. Use all idea of the limit. Okay? Use all idea about the limit. Whatever you want, whatever you use, just use it. No. You should do it. Do it till you'll get a result. I don't know. Maybe you get 0. Maybe you get more things. I don't know. So here we are. Another example. Look. Yalla. N square. So it's converge or diverge. I say by entity. Limit of n square. Directly take a limit. That's why I told you limit is very important. Now is I get what? So is because not a number. It does not exist or it failed to exist. Okay. So you can add also something here like that. When I say does not exist, you can put here infinite or minus infinite also. Anyone. So another example. That one. How about that one? Yalla, equal to what? 1 minus 1, 1 minus 1, 1. The result is equal to what? I don't know. How do you know? By what you say convert? When you say convert, you should prove it. Gadarba. If you just say convert divergence, you will not get any point, any marks. You should prove it. Huh? Take a limit. R, where's R? There's no R. Don't guarantee. Yeah. So just take a limit. So take a limit of 1 over n plus 1. N approximately. So the result of that one is equal to what? We see that in the sequence. We solve something like that in the sequence, right? But once you end the sequence, right? So by entity, because does not exist, is diverge. You got it now? So we took a limit. If the limit give me infinity, I say that does not is diverge. If I got a number, again I say diverge. If the limit does not exist, I say diverge. If I got number, minus 1 over 2, again diverge. I don't care about anything. The important thing is what? You don't get 0. In entity, the important thing is what? You don't get 0. And that's why I say if you get the 0, if possible, series diverge or converge. You cannot say anything. So entity is 99% useful whenever 100% is unuseful when you get a 0. So when you get 0, you don't decide. You should go to another thing that we are going to get it. Understood, Jamaat? So here's some rule which is not hard. You can, if that on converge and converge, like a limit, you can see that on converge, converge. If you have a subtraction, again, you can say. If you have a number, you can bring it to out. Look at here, like a number 5 we did before. You remember example in that one. So proof is not included, of course. So read that one. Homework and homework. It's very important to read it. Just read it. Okay. So look at the example number 9. This is the last example that we have, I think. We have 3n minus 1, like that. 3n minus 1 over 6n minus 1, n from 1 to infinity. Like any other things, like previous examples in the college algebra and calculus 1, anything that you have, we can play with the summation. It's like a limit. So I can say is equal to what? Is equal to 3n minus 1 over 6n minus 1 minus 1 over 6n minus. Why? Because the common denominator. And I know 3 over 6, right? Am I right, Jamaat? And I know is equal to what? 1 over 2. So we got what? We got 2 geometric series. Am I right? Come on, dears. If you saw something like that, you should know about it. It's a geometric and it's equal to what? Because we have a 2, 3, 4. Let's see. So tell me about that one. It's converge or diverge? Converge. R equal to what? How about here? Converge or diverge? R equal to what? Right? You can distinguish. So we have that one and that one. So you can see from here, you bring it like that. So y is equal to 1, 1 minus 1 over 2, you know, the summation of the geometric series, right? And also that one is the summation of another geometric series. And that one will give you that, and here's the result. How about 4 to power n? We make it like a 5, right? We bring it to out, and you got 1 over 2, 1 over 2, 1 over 2. Do you have any question? The graph? The graphs, as we have like a ball, like that, like a wave. It's going to 0. It's converged, like here. We have a graph here. Here's a graph. It's talking about the graph again. Look. And also generally, here's the graph of it. Term by term, like an area. Term by term, you may have a decrease or increase. For example, if I have n, I say n is equal to, when n is 1, I'll get 1. N 2, I'll get 2. 3, 3, 4, 4. You can see we are going to increase to infinity. Understood? Can you imagine? Just like that. And because it's summarized something, for example, you can, as your question is like that, if I put 1 plus 2 is equal to what? The image of 2. So I say if I have 1, I'll get 1. If I have 2, I have what? I have 3. You know why? Let me give you more explanation. Look there. We have like that. So n from 1 to infinity, okay? So, and here's the picture, the graph that you see. So n1, I'll get 1. n2, so 1, 1. Sorry. n2, when n2, I say 1 plus 2, I'll get what the output is 3. So 2, 3. So here we are. n3, I'll get 6. Okay, so go on. The graph is like that, if you like it. Can you imagine? Last thing here, we have what? We have adding or re-indexing. Re-indexing means that play. I did also that one for you. We can sometimes write 1, 2, depends on our duty. For example, if I have len of n, I'm not going to put 0, right? I'm not going to put 1 because I know the first term will be 0. So it's better to write what? N from 2. You know what I mean? So this one's called adding or re-indexing. Look at here. Adding or deleting. Look, we have what? N from 1 to infinity. You can say 1, 2, 3, till k, and from k to infinity. What do you mean by that? For example, I say n from 1 to 100. Okay, so I'm going to make something like what? Like 1, 2, 3, and plus what? Yalla, tell me. N from what? I say n from 4 to 100. Am I right, dears? Maybe we need 3 terms to expand 3 terms. So the other one will be from 4 to infinity. So the 200. For that one is equal to that one. So this means adding or subtracting. You can see 1/5 till 3 terms, and we keep the rest to the other side. Each, or for example, in some books, you maybe in your MSc, inshallah, you saw something, they delete it, they bring it, they add to imagine. That's all the same. Here we don't need actually. Also reindexing. Sometimes I say, if I have 2 to power n, I say what? N from 0. Am I right? From 0 to infinite. How about if I change to n minus 1? I say n from 1 to infinity. If I say n from minus 5, I say n from 5 to infinity. So this one's called reindexing. Index means that the power here, there's index. So now you can see from n plus n minus. And here's the examples of reindexing. Look at here. N is from 1, because if I put 1, I will get 1 here. It will be 1 to power 2, 0, and equal to 1. Now, how about that one? The same. How about that one? The same. All of them the same. So our lecture is finished for today. And we finished 2 to power 2 to power, okay, 1, 2 to power, sorry, 10 to power 2,